electrical systems. We can simulate a normal circuit. Apart from circuit, I want to demonstrate how can we perform LCD display and decoding in electronics process. How can we visualize the results? And also, we want to study the motor drive system. How can we simulate real systems? These are the electrical systems. And for electronic systems, what we need to do is how can we model operational amplifiers, because it is very useful in control. And I will demonstrate some of the particular details in operational amplifier simulation. And also in digital system, we have flip-flop simulation and signal generator to generate an IM sequence, which are useful in identification and in communication. And then I will give further examples on electronic circuits with child. And also I want to demonstrate how can we embed a spice model into a simulating block diagram. And since spice is a very useful language to describe electronic systems, how can we embed that kind of programs inside a simulating block? And also I shall give you some demonstrations on mechanical systems and also on video and image processing problems. So now let's consider the circuit problems. So suppose there is a 3-segment LCDs and there is a binary 4-channel of binary input signals. So how can we decode the signal and display the results using LCDs like this? If we want to display 1 here, if the 4 signals are given by 0, 1, 0, 0, 0, 1. So we want these 2 LCD to be on and the rest are off. So we can display 1 in that case. So we need a truth table like this. And this 2 means it's 2 segments. And you can get this kind of truth table easily from an electronic book, I think. So if there are 4 channels of input to a block like this, we want to display in a numerical way or even in LCD. How can we display the results? How can we get the results? For the original problem, there are 4 channels of binary input and the truth table. How can we display the results? I've shown a lot by using the scopes. Here, I want to explain more on the display of signals. So let's go to Simulink again. We will see that there is a group called Gorgeous block section, which are active F applications. And so we can double click this part and we can see that there are different kinds of blocks. For instance, we can have meters, a certain type. I'd better open this library in an alternative way. If we double click it, then we should have a block set library like this, and this one is the one that I want to explain, the Gorgeous. We double click it, we will have displays like this, and in this group there are some useful active X components. For instance, you have angular Gorgeous, and you can connect this kind of components to a signal in the simulation system, and you can visualize the result. Instead of viewing the curves, you can visualize the result with the meters. there are quite a lot of similar things. And here in particular, I want to demonstrate the LEDs. So LED is something like this. If the signal is 1, the input signal to it is 1, then it will be lighting. If it is 0, then it should be remain things like this. So we can use this kind of components to construct a simulation diagram. Set the task. So this is the block diagram I want to create. In the block diagram, we have 4 input signals. And these input signals are generating binary signals. And I will explain this part to you later. And there should be output there to drive the 7 LEDs. And I can arrange 7 LEDs to the shapes like this. And now here we have to implement the truth table for that kind of decoding. And this block, this one will generate continuous signals. And this one will require binary signals. So we have to convert the continuous signals to binary signals. And also, these LEDs require continuous signals. So I have to convert the binary signals to continuous signals, like this. So this is a block diagram I created myself to display the decoding and LED displays. So if we try to simulate the system, what we should get is the LED displays. So in that case, you can not only see the curves, but you cannot see the curves, but you can visualize the result by LED display. I think later I think I will copy this file to you if you are interested in it. Oh, this is a whole block, or you? No, 7 blocks. I arranged it myself. Because I think you can save it later. If you arrange it, then you can save it later. Or later you can save it as a subsystem or something. So there are a few important things in it. One is the LED displays. They will accept continuous signals, so we have to use conversions of data. So let's go back to the library and see where are the blocks. Maybe I cannot find this blocks easily. Here, the data conversion. So it should be in signal attributes. In different versions, some of the blocks are distributed differently in different groups. So the data conversion, there is an automatic data conversion in it. And you can also specify the way to transform or convert a signal. In the signal routing group, we have MUX and BEMUX I explained earlier.